In this demonstration, I'll show you 3 examples on how to find the derivatives of exponential functions. The rule when it comes to finding the derivative is the following. Notice that this part of the equation remains the same. You also find the derivative of the exponent, and then the base of the exponent becomes the ln of that base. Let's start off with question number 1. Here we're asked to find the derivative of y is equal to 2 to the power of x to the power of 5. So we will use this rule and we will rewrite our equation 2x to the power of 5. We're going to find the derivative of this using the power rule, which is 5x to the power of 4, and you can enclose it in brackets, and then ln 2. So we'll rearrange everything. We'll have 5x to the power of 4 times 2 to the power of x to the power of 5 times ln 2. That's it. Moving on to question number 2. Here we're asked to find the derivative of this function. We'll start with this. You'll notice this 2 that's enclosing this bracket. We bring that 2 down. It's a matter of the chain rule this time. X to the power of 6 times 6 to the power of x plus 4x. 2 minus 1 is 1. And now we will find the derivative of this. This is the chain rule. We'll start off by finding the derivative of that using the product rule. The product rule tells us that we need to find the derivative of this, leave that the way it is, and then add the derivative of this and leave that the way it is. So 6x to the power of 5, using the power rule here. We're going to leave 6 to the power of x the same, plus this part, which is 6x, and we're using this pattern right here. Find the derivative of x, which is 1, and ln 6. And we will now leave this part the way it is, x to the power of 6. In addition, we have to find the derivative of 4x, which is 4. We're going to close this with brackets. And lastly, the derivative of that is equal to 4 to the power of x ln 4. Next question is a biology-based calculus question. The question reads, based on data published in 1990 by the International Panel on Climate Change, if the trends of burning fossil fuel and deforestation were to continue, the atmospheric carbon dioxide level in parts per million would be approximately C is equal to 353 times 1.0061 to the power of x minus 1990, where x is the year. Find C in 2007 and interpret its meaning. So let's start off by finding the derivative of this function. And we're going to use the same logic as we did before, that same pattern. We're going to leave this the exact same way. And next, we'll find the derivative of this, which is equal to 1. And then the ln of the base, which was 1.0061. Next, we will input the 2007 date and see the number 1.0061 2007 minus 1990 times ln 1.0061. We're going to use our calculator now. 253 1.0061 to the power of 17, subtracted these, times ln 1.0061. And we get 2.38. This number suggests the rate at which the CO2 levels are changing in 2007. So there you have it. 3 solid examples on how to find the derivative of exponential functions. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.